Okay, so today we're going to be talking about what it means to be a function that is derivable. Now, in year 11, we talk about classifying functions or relations. So for us to be able to derive something, we need it to be a function. Well, for what you guys learn anyway in year 11 methods, you need it to be a function. So that means that it needs to be in the order of either 1 to 1 or many to 1. Okay, so like down here, see how for every one x value, there is one y value, or there is two y values, that's fine. But that's what we're looking for. This one here is not a function because it has two x values. So the other thing that we're checking for when we're trying to see if something is derivable is that it is smoothly continuous, which means that something like this doesn't fit into what we're talking about because it's got a sharp point. So if I look at the point just before where I would be deriving, this has got a positive gradient. And if I look at the point just after, it's got a negative gradient. So if I try to integrate at the point of A, it's not going to marry up nicely. We can't derive if it's a pointy thing like that. The other thing that we can't derive is if functions are not continuous. So by that, I mean that sometimes we get a piecewise function that could be like this. So it's linear up to that point there, and then it's including this section here. It's got a bit of a disjunct, and then it's got another point up there going like that. Now, this is not derivable at this point here, or x equals whatever that value is, because it's not connected there. So you can't derive functions that fall into this category of not being connected or not being smooth. Okay, so let's look at our worked example. So we've got a function that's defined by this, and it's continuous at x equals 1. Test whether the function is differentiable at x equals 1. Give the rule for fx, stating its domain, and sketch the graph of y equals f dash x. Okay, so first thing that we are going to do is we're going to test it, which means that I'm going to, give me a second. So we're going to test it in both functions. So the first one I'm going to test it in is this one here. So f of 1 is equal to 1. Good. Now we'll test it in the second one. F of 1 is equal to 1 squared, tick. That's also equal to 1. Therefore, it is continuous. At this point. Okay, so now next we want to give the rule for f dash x, stating its domain and sketching the graph of this. Now, at this point, we have learned how to derive using the formula, which is great for us. So if I'm going to give a rule for it, that means that f dash x is going to be equal to the derivative of this first function just becomes 1. X keeps the same values. And for this one here, that 2 will come down and multiply the front of it. So it will be 2x. And then when we subtract 1 from this top, it will become just 2x. Now, I'll do the working for that to the side because this is still kind of fresh. So this comes down to the front, 2x. And then this is reduced by 1. So 2x to the power of 1, which of course simplifies to 2x. Okay, and then that's x like that. So this is the way that I state a given rule for the derivative of this polynomial function. Now we're going to sketch the graph of y equals fx. So we're just sketching this graph. So that means we throw my axes in. So for all the values where x is less than or equal to 1, we're going to just be the value of 1. So up to here and including that point and all the way back that way. I'm just going to put my arrow on the end there. Now for the next section, this one here, that should have been blue. Okay, now we're going to follow that rule. So when x is at 1, the gradient is at 2. And when x is at, let's just pick another value, at 2, the gradient is going to be at 4. Now, I'm just picking this second point so that I can get something to throw in to give my graph some points. Now, this one here is not including, which means that the middle of it shouldn't be shaded in. Okay, because it's included in this point down here. Okay, so give the rule for f dash x stating its domain and sketch that graph. So let's just double check that we've done all the things here. I haven't stated domain. That's something that we're going to have to come back and do. Still here, just double checking that I've crossed my T's, dotted my I's. So, because when we substituted these values in, they didn't also give me a point that was continuous, then we can't say that this is going to be continuous at that point. So, test whether the function is differentiable at this point. We needed to substitute this in as well. That should be a 1, f dash 1 equals 2 equals 1. So, therefore, it's continuous at this point, but it's not differentiable. Okay, and then we've gone down here, we've sketched our graph. Now we're going to state the domain. And the domain is your possible x values. So, in this direction, I can keep going past the graph. It's always going to have a value going this direction, which means it's going down to negative infinity, all the way up to, and then in this direction, we're going all the way up, whee, to positive infinity. So our domain can be any value between the two. Or if you look in the textbook, it says it can be any domain of the real numbers.